Hey, this is Maths Athlete. Welcome to the second lesson on surds. Today we'll be looking at the rules of manipulating surds. This also covers the topic of simplifying surds. To start off with, let's look at the first rule. Now, I write my rules in green so they stand out. So the first rule, so let's write first rule is that the square root of AB equals A times B. Now this is a key rule that you need to know when you're asked to simplify, and this also comes in rationalizing surds and so on. So if you don't know this already, I suggest you keep watching. So this is the first rule, so let's give an example. So if you are given, say, the square root of 18, you can also write it in the fact, so a times b equals 18, so you write it in the factors. So you can write square root 2 and square root 9. And then we come to simplifying surds, because we know that the square root of 9 is 3. So now we have equals 3 root 2, and this is a simplified version. So this rule is a key rule, one of the key rules for manipulating and simplifying surds. Let's look at the second rule now. Okay, so the second rule, also in green, the second rule, which is that the square root of A over B, let's do an arrow, is the same as, should we say equal to, the square root of A over the square root of B. Now you can have this in many examples. So say you have the square root of 25 over 16, that will be root 25 over root 16, and because we know our squares so well, we know that that's 5 over 4. So these two rules that we've mentioned so far are very handy, and now we're going to look at examples. So we are asked to simplify root 24. So I suggest we use the rule, let me write it in green again, square of AB equals A times B. So now let's use blue. Now let's solve it. Okay, so we have many factors of 24. We have 4 times 6, we have 1 times 24, 3 times 8, we have, let me fix that, 8, we have 2 times 12. Yeah, I think these are all the factors. Now, looking at these factors, which of these contain square numbers? So I can see straight away that 4 is a square number, so let's use that. So let's have 4, the square root of 4 times the square root of 6 equals the square root of 24. And I forgot to mention simple algebra is A times the square root of B is the same as root A root B. You know, in algebra, you just put them next to each other and they times. Okay, so just forget about that now. So now we can simplify this. We don't know the square root of 6, and seeing as we're not allowed a calculator in the exam, the best choice was to choose root 4. So now this becomes 2 root 6 equals root 24, and this is the simplified version. If we look at another example, so now we are asked to simplify the 36 over 25 square rooted. And I always say square rooted because this sign only means square rooted unless you have a 3 here, so that's cube root and so on. So now it's just square root. So let's use the second rule. So we write this as, let me use blue pen, square root of 36 over the square root of 25, simple math, 6 over 5. Okay. So I think this gives an overview. Let's look at a final example. Okay, so now we have a mixture of the first rule and the second rule. So let's give it a try. So let's write it in the form 162 over the square root of 81. Now let's write down here on the side the factors of 162. So 2 times 81, which is the same as 162. And notice how I don't need to go any further because I have a square number. So I said, should we just use this? So now let's write it as root 2 root 81 over 81. Now this has become extremely easy for me because now I can just cancel these terms out. And we'll go over more how to cancel out terms when we're adding and subtracting surds. But yes, these two cancel out, so the final answer is root 2. Quite simple. Let's see if you've learnt from the examples. Let's give you a test. Okay, so simplify the following. You can pause the video and do them yourself, or we can go together through them. Okay, so root 50. This is quite simple. If we work out the factors in our head, or we can do it on side, it's 2 times 25. 25 is a square number, so we have root 2 root 25, which equals 5 root 2. So that's done. That's the final answer. We have the factors of 8, which are 2 times 4. 4 is a square number, so we'll have 2 and 4. So now we have 2 root 2. And if you keep on doing examples like this, you get used to knowing the factors and what they will give you straight away. So now we have the square root of 32 over the square root of 64. That is the same as 8. We can have 8 here, and then the factors of 32, we have 2 times 16. 16 is a square number, so we have root 2 root 16. Root 16 is the same as 4, so we have 4 root 2 over 8. We can divide this by 2, and we get actually we can actually divide this by 4, so we have root 2 over 2, which is simplest possible, I think. Yes, it is. Now root 12 over root 60. You have 4 times 3, so you have 4 times 3. Root 4 times root 3, of course, but just for simplicity I say 4 times 3. And then you have 4 and 15. 4 times 15 is 60. We have 2 square numbers that we can both cancel out, so I suggest we do that instead. So let's cancel these out. So now I have root 3 over root 15. We can turn this into root 3 over root 3 root 5, which these cancel out. These cancel out. So now we have 1 over root 5, which looks like something I can rationalize, but let's not get too carried away. Those are for the later stages of the videos. What makes 40? We can have the square root of 4 times the square root of 10, and we can simplify that to 2 root 10. And that's all the examples. Okay. I think that's it for this lesson. If these videos have helped you well, subscribe, comment in the comment section below if you want to give any feedback. If you have any questions to do with maths in particular, you can message me on my channel, and I can possibly make a video. But of course, if there's too much videos, then it will take a few time for me to do them all. So yes, tune in to the next video, which will possibly be more about manipulating surds, but also adding and subtracting surds. I hope this video has helped you well. Thank you for watching, and goodbye.